All right, so we're still going on Unit 2, end of unit test. We're going to go from 5A, and I'm hoping to get through 7. So this one's for 5A. So consider the function rule f of x equals 9x minus 7. So here's the rule, f of x equals 9x minus 7. Remember that when you see this guy, all they're asking you to do is take that 4 and plug it in for here. That's all you do. You take this 4 that's inside the parentheses, because it's telling you to put a 4 into the machine. Well, my machine's right here. So the x gets multiplied by 9 and then subtracted by 7. So let's put a 4 in, and let's simplify. 9 times 4 is 36. 36 minus 7 gives you positive 29. So let's do it again. We've got f of x equals 9x minus 7. This symbol means is telling your audience, we want you to plug in a negative 2. So take that negative 2 and plug it in for x. So 9 times negative 2 minus 7. 9 times negative 2 is negative 18 minus 7. Negative 18 minus 7 gives you a negative 29. No, 25, sorry. Negative 25. Remember, f of x really just means y. F of x is a really fancy way of saying y. So all you're doing when you see this symbol is taking that 4 and putting it into your machine. Taking that negative 2 and putting it into your machine. All right, so now they're asking what's the original value of x if f of x equals 65? Well, remember, f of x is really just a fancy way of saying y. So they're saying y is equal to 65. Well, remember, we've got our original problem of f of x equals 9x minus 7. Remember that f of x is the same thing as y, and y is 65. So when you see this symbol, f of x equals 65, they want you to take out this whole f of x, and replace it with 65. When we do that, we need to find the original value of x. What number could I plug in here that would give me 65? Well, right now, PEMDAS says you multiply by 9, and then you subtract 7 to the number that you put in. Let's go ahead and do that backwards so that we undo the PEMDAS problem. Instead of subtracting by 7, I'm going to add 7, and then multiplying by 9, to undo that, you divide by 9. So let's do that in order. Plus 7, so we're going to plus 7 to both sides. Negative 7 plus 7 is nothing. You get 9x on this side. 65 plus 7 gives you 72. Now, we've added 7 to both sides. Now we have to divide by 9. So divide by 9, divide by 9. 9x divided by 9 gives you the 1x that you're looking for. 72 divided by 9 gives you 8. So if I plug in an 8, I'm going to get the 65 that I'm looking for. We can double check in our calculator. 8 times 9 minus 7. Try it in your calculator now. 8 times 9 minus 7 does give you 65, so we're correct. Okay, so for each problem, identify the independent and dependent variables and write an algebraic rule. Well, this one should have been pretty easy. The independent is always on the left or on the top, depending on your table. And your dependent's always over here. So your independent is number of cases, C. The number of bottles of water is your dependent, that's B. Now let's look at the algebraic rule. If you take a look, all you have to do is multiply by 24 each time to get your B. So your rule, remember, is always this letter equals, so B equals, this number is always equal to this number, C, times 24. All you have to do to get this number, you take this number and you multiply by 24. All right, let's see if we can keep going. For each problem, identify the independent and dependent variable. Well, we've got a situation here. We've got you're ordering pizza from Tampa Pizza. They charge $7 per pizza in addition to a $4 delivery charge. I gave you a hint. It might help to make an input-output table. So if we do an input-output table, what are the two things that change in here? Well, it's the number of pizzas that you order, and the number of pizzas are in charge of your total cost. So let's try it for 0, 1, and 2 pizzas. If I order 0 pizzas, I still have to pay the delivery charge of $4. So I'm going to pay $4. If they charge $7 per pizza, notice that per is there and pizza is here. So this is our X and this is our Y. You've got your 1 pizza times the $7 that it takes to pay for that, plus the $4 delivery charge. 1 times 7, that's only $7 for the pizza. Then plus 4, you've got $11. Let's see what we have when we have 2. If I buy 2 pizzas, they're each $7, so that's 14. Plus another 4 for delivery charge, you have 8. Now that we've made our little table, I think we can probably come up with our independent variables and our rule. Well, independent's always on the left, so you've got number of pizzas. Dependent's always on the right, so you have total cost. For those of you that put the delivery charge never changes. Variable means vary or change. The delivery charge never changes, so it can't be the thing that's changing in the problem. Now let's take a look at our rule. It's always this equals, so it's Y equals. So the total cost is equal to the number of pizzas that you order times 7, and then you add the 4. 7 times the number of pizza plus the $4 delivery charge. Take a moment now to go ahead and pause it and write down what you need to. Make sure that you're taking a moment to pause it also and write down what your mistake was. That's part of your grade. All right, let's see if we can squeeze in one more here, 8A and 8B. We've got to take a look at this table. We've got to find the independent and dependent variable. Well, this is your X and this is your Y. Your X is always your independent, so your independent's number of miles. Your Y depends on X, so he's dependent, so Y is the taxi fare or the taxi cost. Which makes sense. The number of miles that I drive in a taxi determines or is in charge of the cost that I have to pay the taxi guy. So that makes sense. Now we've got to come up with a rule. I gave you a hint that it might help to make the input-output table. So let's go ahead and make the input-output table. Here's X, the number of miles, and here's Y. When X is 0, Y is 4. Let's try another one. When X is 1, Y matches up with 6. When X is 2, Y matches up with 8. When X is 3, Y matches up with 10. So I think we can get it from here. We've got to figure out what to do to get from here to here. What do we have to do? Well, let's see. I gave you a hint a couple of times during class that whatever this number is, where your line crosses the y-axis or touches the y-axis, is the guy at the end. So if we want to come up with a rule, y equals some number x plus some number, the 4 is at the end. If this guy crosses or touches the y-axis at 4, there's a hint that the ending guy is going to be 4. So now we've got to figure out what can I multiply this guy by and then add 4 to get 6. Let's try 1. So if I multiply 0 by 1, I'm going to get 0 plus 4 is 4. That works. Let's try it for another one. If I take 1, multiply it by 1, I get 1 plus 4 isn't 6. That's 5. So that doesn't work. So it can't be 1. Let's try 2. I'm going to give myself a little bit more room here. 0, 1, 2, and 3. If I take my 0 and I multiply it by 2 and then add 4. 0 times 2 is 0, plus 4 is 4. If I take my 1, multiply it by 2. 1 times 2 is 2, plus 4 is 6. So that works for that one, works for that one. Let's try one more. 2 times 2, put the 2 in, multiply it by 2, then add 4. 2 times 2 is 4, plus 4 is 8. So it works. So to get the y, I always have to take my x, multiply it by 2, and then add 4. So to get this number, I have to take this number, multiply it by 2, and then add 4 each time. So let's try it for one more time. 3 multiplied by 2, 3 times 2 is 6, plus 4, yep, that's 10. All right, so we'll do the rest on the next video.